right, so before we get to the specific intermolecular forces, let's just take a look at one more concept, and that's phase transitions, right? So what we're talking about is going from maybe from a solid to a liquid to a gas. And then if we think about what's going on the molecular level in a solid, right, these two things are held together tightly by intermolecular forces. And then on the right side, gases, right? The gases are acting basically independent of one another. And so there's not really any intermolecular forces keeping them together. And when we go from left to right, what we're doing is we're adding energy to this system when we go from a solid to a liquid to a gas, right? And that makes sense. In a solid, you can have ice. When you heat it, add energy to it, you form water, add more, you'll eventually form steam. So as we go from solid, liquid to gas, we're increasing the amount of energy. And where's that energy going? Well, it's going to break these intermolecular forces, right? The solid has intermolecular forces, the gases do not, essentially. And so that energy is going to break the intermolecular forces, right? So energy is required to break intermolecular forces and go from a solid to a liquid to a gas. And then the next kind of interpolation of this kind of idea is that the stronger the intermolecular forces are, the more energy is required to break them. And so the way that manifests itself in the physical properties is that if you have very strong intermolecular forces, you're going to have higher melting points and boiling points. And that makes total sense because it's going to require more energy to break these stronger intermolecular forces.